In the previous video, we learned how to construct functions using recursors. But in this video, we are going to generalize that notion to dependent functions. We are going to investigate inductors. Let's get started. Suppose we wanted to construct a dependent function from the natural numbers to a type in the type family B. We can then define the inductor for natural numbers in a similar way we defined the recursor. We start by picking a type family from the natural numbers to some universe. Let's call it C. We then pick a term in the type that C sends the term 0 to. Next, we pick a function that, given some n in the natural numbers, defines a function from Cn to C suc n. Finally, we are left with a dependent function that maps every term n in the natural numbers to the type Cn. Note that the inductor for natural numbers is a generalization of the recursor for natural numbers. In other words, the recursor is simply a special case where we define the inductor for a constant type family. So, how do we define f? Well, we do it the same way we did with the recursor. We apply the inductor to B, B0, Bs. And similar to the recursor, we define f0 to be equal to B0 and f suc n to be equal to Bs applied to n Fn. But we can go one step further. We can apply inductors to propositions. For example, to construct a proof that the proposition P is true for every natural number, we need only construct two terms. Firstly, we construct a term in P of 0. We call this the base case. Secondly, we need to construct a function that, given some proof that P of n is true, it returns a proof that P of suc n is true. We call this the induction step. It may now become clear that this is none other than the type theoretic analog of mathematical induction. Thanks for watching.